So I wanted to talk about other repair technologies other than TEER, but to start, I think the most important thing to say is that there are no other technologies that are approved currently. So a lot of what I'm going to be talking about is what's experimental. But just getting back to this concept, I think that Sushil mentioned earlier in the day, is this concept of the interventionalist toolbox when we're looking at how to approach repairing the valve. And so we may require this toolbox mentality if we want to try to mimic a surgical approach to repairing the mitral valve. And, we're not all going to have 10 essential tools in our toolbox, but maybe what we need is 3 essential tools in the toolbox for interventional cardiology. And I put in green leaflet strategies because we do have approved technologies for this, which is TEER. But perhaps the other 2 things we can think about, if we think about what's essential for the toolbox, is a chordal strategy and then maybe an annuloplasty strategy. And so if we think about mitral valve repair, this is the anatomy, obviously much more complex than what we see with aortic valve. But we see that particularly primary MR is a disease of the mitral valve and the associated structures. And often what we see, like the case we saw earlier this morning, is we get rupture of primary or secondary cords, we get a flail of the mitral valve leaflets. And so this concept of chordal repair offers the opportunity to repair the valve by presenting new cords to support the valve leaflets, and then thereby reduce or eliminate mitral regurgitation. And so obviously if we could have transcatheter chordal repair, the beauty of it would be being able to address the anatomic defect, the abnormality, and then not necessarily closing the door on future, for example, transcatheter valve replacement, if in fact that was the choice we made. The other option is this could be combined, much as the way surgeons do a combined repair, and we could add an annuloplasty if required. And if we had to choose our ideal device, we would want it to be transeptal. We'd want to be able to put multiple cords and address pathology of either the anterior or posterior leaflet, and essentially respect the geometry of the heart in terms of how we're going to put these anchors. So I'll show you a couple of devices which are in clinical research at the present time. And so this is the NeoCord device, the NeoCord Nexus. You can see that there was a transapical version of this, but what we want to focus on is more the transeptal version, sort of that it enables us to add cords and repair the mitral valve. And so this is a transeptal approach. This device uses a cord placement monitor to let you know if you've captured the leaflets, and the anchors are placed in the papillary muscle much in the same way that surgeons place their sutures when they're putting in neocords. You can use multiple cords on a single anchor. You can tension these under real time and evaluate them under echo, and the implant itself is quite minimal. There have been some successful cases. And the EFS is currently enrolling. One of the things with a lot of these technologies is they move a couple of steps forward, maybe a step or 2 back, and then they continue to move forward. And so, this has had some successful cases. There's been a little bit of a pause. I believe they're resuming, but there are challenges with these technologies, which is why none of them have been approved as of yet. But they do show some important promise, and this is just some animal studies showing you how these anchors can be incorporated into the tissues. And so this may be the future. Let's keep our fingers crossed. There are other devices as well, and so this is CardioMech, and this came out a couple of years ago and has now been redesigned and is entering back into the research space. But this again is a fully percutaneous transfemoral transeptal system which uses one cord. You can again tension the cords under live echo guidance. The anchors can be repositionable, and the point of no return is relatively late, so if the outcome isn't good, you can reassess. And again, as much with the other chordal technologies, it does preserve future surgical or transcatheter options. This is a rather interesting device. It looks like a basketball net to me, and I show it to you because it's sort of strange out of the box, and maybe this is what's going to be the solution, and this is what's called the CALA TMVR system. And essentially, this is composed of a ring, a net, and these sort of cords that come with it. And it attempts to do everything with one device, chordal replacement and annuloplasty. It has this expandable, compressible ring. It has to attach to the annulus with 5 anchors. It does cover the leaflets with this net-like concept and expands with the ring to be a one-size-fits-all. It supports the leaflets theoretically, can treat P2 prolapse as well as Barlow's, and it claims to be agnostic to the actual anatomy and can potentially prevent future valve difficulties. I'll just show you the video that's associated with this. This is a 29 French transfemoral system. It's been done in animals. I believe they have one human case, but it's something different, something interesting. Is it going to be the future? It's hard to know. Get to a later point when we talk about the toolbox in terms of the interventionalists and how many things we're going to be able to learn. But this is what the proposal is for this device. This is how it claims to be able to work. So it's intriguing. It's interesting. Is it going to be the future? It's hard to know. And this is what we see in the animal study. So in terms of the other things we need in the toolbox, talked a little bit about chordal repair. Obviously, annuloplasty is the mainstay of surgical mitral valve repair. And the surgical annuloplasty has a long history. It's adjunctive for primary MR and eventually standalone for secondary MR. And if you look at the STS database and you look at that sort of mitral repair toolbox of the surgeons, in 94% of cases, they're using an annuloplasty. So that begs the question, as interventional cardiologists, why aren't we doing that? And so we're trying to get there, and it's been a bumpy road. We still haven't gotten there completely. This is a slide that I borrowed from Isaac, but essentially shows you this concept of taking a surgical ring and turning it into a transcatheter device. And the attraction, or what makes annuloplasty attractive, is this ability to reduce the AP dimension and assist in terms of restoring mitral valve coaptation. And so this is the amend device. It's a transeptal approach. It's a direct annuloplasty repair. So the annuloplasty ring is placed in the mitral annulus. It's a D-shaped, much like a surgical ring. It has this anchoring mechanism. And again, it replicates this gold standard of a surgical solution and gives you this AP reduction. And it can enable you to combine this with other procedures, be it chordal repair, be it edge-to-edge repair, and could potentially serve as a docking station for valve replacement in the future. And so they're not the only people working on an annuloplasty system. This is the Solera system. This is a slide I obtained from Gagan Singh, and this is another system that's trying to perform a direct annuloplasty, reduce that AP dimension. It has anchors. There's a medial trigonal anchor, a lateral anchor, and then that posterior bar that you see. Advantages, again, reducing the AP diameter, may potentially adapt to various forms of FMR, and very low profile in the left atrium. It's hard to know. They have one case that's been performed in Paraguay that was successful, but there's a lot of unknowns with this technology. And this is what this looks like. You see this posterior annular bar. You see those medial and lateral trigonal anchors, and you see how it's being cinched in and providing that annuloplasty effect that you can effectively dial in to achieve what it is you're trying to achieve. So in summary, the idea of this toolbox is a very attractive idea. It's promising. It focuses on probably what are the most likely 3 strategies. If you think of your own toolbox at home, I suspect what you're using most of the time is a hammer, a wrench, and a screwdriver. And so we're trying to reproduce that hammer, wrench, and screwdriver by attacking the leaflets, the cords, and the annuloplasty. And so we're still early days to establish both the safety and the feasibility. And they're promising, and hopefully we're going to grow the armamentarium of devices that we have at our disposal. But it does raise the question of training and maintenance of competency. And depending on how complex the devices are, we're going to have to master all these in order to be able to provide good results for our patients. So thank you for your attention.